Hello students, welcome back. In this video, we're going to add a resource system to our game. This is something the player is going to have to manage and keep track of as they go through playing Factory Frenzy. And this is going to come in a system, orders. So our game will create orders that the player has to fulfill. Maybe an order consists of 2 red widgets, 3 yellow widgets, and 1 blue widget. And when they complete that order, the order will get shipped and we will score points. So let's head to the computer screen and we'll dive right into this new resource system of orders. So I have lesson 4's starter file open here in vscode.dev. I'm going to minimize this and we're going to open that file directly in the browser and let's see where we are at with our game. So here is our starter file. Okay, our game is completely broken. What a great place to start in. That means we just got a lot of work to do. But one of the things I'll note here is we got some new information up here in the HUD. In our HUD, it looks like we're displaying some score because we said every time we complete an order and that order gets shipped, we are going to earn some points. We're going to make the big boss man proud and they're going to reward us with some points. So let's head to the computer screen and let's dive right into lesson 4 on fulfilling orders. So mission 1 has us creating the order data structure, but before we get to that, I think I want to just go through and let's look at what we have to work with here in our order system. So we're going to head to the student edit zone. I'm going to scroll through. Here we've got our player system, our belts, our widgets, and now here we see some constants that we can tune. We can adjust to change how the order system sort of plays or feels or looks within our game. And so we have an order minimum per color set to 1 and an order max per color set to 3. And then an order score value per widget. Okay, so I think I'm going to wrap my head around these variables here. So we have yellow, blue, and red widgets, right? Each order has to have at minimum 1 of each of those, and at maximum 3 of them. So those are our minimum and maximum values. And then we're saying for each widget in an order, you're going to get 25 points. So if your order only has 1 red, 1 yellow, and 1 blue, you're going to get 3 times 25 or 75 points. If you got 4 widgets total, you're going to get 100 points. If you got 5 widgets total, you will get 125 points. All right, so those 3 constant values we'll use for our order system. Let's go look at our color palettes. Do we have anything new here in our color palette? Doesn't look like it. Nothing new in our color palette. If we scroll down, what about our gameplay variables? Okay, so we got a couple of new gameplay variables. We have our current order, and our current order is going to be an object. Okay, so we're gonna make our order an object, which would have properties. And I'm assuming some of the properties of our order might be like a red property. So like how many red widgets we have and how many we fulfilled. So maybe like the red property might be like 0 out of 2. And then a yellow property, 1 out of 3. And a blue property, 0 out of 1. So it'll keep track of a current order. And we're only going to have 1 order at a time here in our game. So just 1 order that we're trying to fulfill. And then we got a score variable, which is set to 0. And that must be what we're displaying right here, our score of 0. Okay, so that is going to be our order system. So with that overview, let's go look at mission number 1. Okay, so look here. We are creating an order object. We're going to put something into our gameplay world. And just like we did when we talked about putting widgets into our world, we said, hey, we are going to have 3 functions that help us do it. We're going to generate our widget data, we're going to spawn our widget, and we are going to update our widgets. Our order is sort of no different. So if I scroll down here, I've got generate order data. I've got spawn order, and I've got update order. So this same structure is repeated over and over and over again. So let's look here. In mission 1, it says we are going to create the order data structure, set required and boxed values for each color. So we are returning an object that represents our order, and it looks like our object right now has 1 singular property, red. And its property is another object. Ooh, wow, this is amazing. So our object has properties that are other objects. So the red property is an object that has a required property, which is going to be how many reds we require for a given order. And it looks like we are figuring out, we're picking a random number from our minimum color 1 to our max color 3, and then we're adding 1 to it because this could give us a decimal, okay? This could give us like a decimal value. Between 1 and 3, we could get like, I don't know, we get like 2.7. You can't have 2.7 red widgets in an order. So what we're doing is we're calling the floor function. And that says take this number and just cut the decimal off. So it's going to give us 2. So we have the ability to get 1, 2, up to 3, but then I add it, so I go up to 4. So this way, by going up to 4, I could get like 3.99, and if we floor that, call the floor function, that's going to give us our 3 right there. And then what do we got next? We have a boxed property, which is how many we've actually boxed of that color. So we set it to 0. So I think we just got to sort of mimic this, right? We need 2 more properties. So I'm going to go inside of my object that we're going to return here, and let's create a blue property. Blue. Let's make it all capital letters, all capital letters. And so this is going to be an object that has properties, a required. And we're going to say, okay, we're going to use the floor function to cut off our decimals because you can't have a decimal amount of widgets. And then we're randomly going to select from order min per color, so tab to autocomplete, to order max per color, tab to autocomplete. And we're going to add 1 so we can make sure we get that final value. And then we'll put another property in here. We'll call it boxed. How many of these have we actually boxed? Well, to start at the order, we have done 0. And then we got to do that again for yellow. Now, if you are a fan, you can just copy and paste it, but I'm going to type it out because I think finger exercise, muscle memory is important. So we're going to say, hey, we have a required property right here, and it's going to be the floor function. So we get rid of our decimal. We're randomly going to select from order min per color to order max per color, and we're going to add 1 to it so we can get that final value. And then we're going to create a boxed property and set it equal to not 90, set it equal to 0 because we have not boxed any of them at the start of our order. I believe our data structure is now built. It is complete. Maybe that was why our game was crashing. Let's take a look. Nope. That was not why our game was crashing. There must be something else going on why our game is crashing. But at least this order data object is correct. So mission number 2, if we just look right here, we now got to spawn an order. So we created this data structure in generate order data. Now I need to spawn a new order. Set the current order at the start of the game. Okay, so didn't we just have a variable or a gameplay variables? I'm going to jump. You can stay here. If I jump up to our gameplay variables, I have current order, which was originally just an empty object. Well, we got to fill it. Let's put a new order in. So I'm going to target that variable, current order, and we're going to set it equal to a new order. Now, where do we get this new order from? Well, we're going to get it from the function we were just working in, generate order data, because this order that was just created for us, right? We're randomly going to select. We're going to say, hey, you are required to have, I don't know, 2 yellows, 1 blue, or 2 reds, 1 blue, and 3 yellows. We are returning that order. So this object right here is going to get returned to us, and we're going to store it in the variable current order. The way we do it is by calling the generate order data. Tab to autocomplete. We're going to call that function. Set a parentheses to call it. All right, so now we have an order at the start of a game. Let's take a look. Ooh, now our game isn't broken because that order exists. We must have been looking for it at the start of our game, and it was nowhere to be found. And now that it's there, all right, so it's sort of operational. The system is sort of operational. Can I put a red thing in there? Hey, I'm giving you red widgets. Is this our order? I don't know. Like we've got 1 red square here, 2 blue squares. I see no yellow squares. We're supposed to have yellow squares because didn't we say the minimum number of each color was supposed to be 1? So something's busted. Something's still broken. Let's go to mission 3 to see what happens. Mission number 3 says draw order. Okay, so we got to draw the order. So we find ourselves down here with all of our other draw functions. Let's just make sure we're calling these. So I'm going to go up here to draw scene. This is where we're calling like all of our draw functions, right? So I got draw background, draw belts, draw boxes, draw widgets, draw player, draw HUD, draw start overlay, draw lose overlay. Oh, I'm not drawing the order at all. Well, you know what? our order is in our HUD. So maybe we're going to call it from draw HUD. Let's go check. So I'm going to scroll down just a little bit to the draw HUD function. And here it is. So we put all of our text, and you can see, I should have seen it. We were right there. We are going to draw our order. Now inside draw order, it looks like we create a variable called center offset. And we set it to 140 pixels. And then it looks like I'm calling a function, draw order squares, and I'm calling it twice. Okay, so that function is right down here, draw order squares. If you look, our order is made up of these little squares. We've got one red square, two blue squares. If I refresh the page, do I get a different order? Ooh, look at that. Now I got one red square, three blue squares. Now I got 1 and 1. Now I got 1 and 3. But I never have any yellow squares for some reason. Well, okay, so draw order squares is going to be taken care of, I think, drawing each of those colored squares in our order. We're calling it for red, we're calling it for blue, but we are never yet calling it for yellow. So I think we got to do that here. We got to complete the order. We got to draw the entire order. We got to have red, yellow, and blue. So let's call the draw order squares function, and let's figure out what information does it need. Well, we can mimic the structure that's up here in our function calls, or we can just look at the function itself. It says we need a color. We probably, what we need, the number done, the number required, and the center X. Okay, well, let's figure this out. We're going to figure this out. So let's pass in our color. Our color is, we pass in red box color, blue box color. We're going to pass in yellow box color. And then we have to pass in, how many are boxed? Okay, so if you look here, we access our current order. Do you remember where we set this? You can stay here. I'm going to jump around. You stay here because it's important for us to understand how this data structure works because it's pretty complicated. It's pretty complicated. So our orders, here's our orders. Our orders are a dictionary, so we're going to access one of their properties, red, yellow, blue, or yellow, and those properties are dictionaries, so we're going to access one of their properties, required or boxed. And our order is called current order. So we're going to look at that data structure. So we're going to target current order, and we're going to access one of its properties. We are going to access its yellow property this time, and that yellow property is another object, and we're going to access its boxed property. So how many yellow widgets have we boxed in this order? Then what do we have to pass? We have to pass in the required number of widgets. Well, we're going to mimic this exactly. We're going to say, all right, current order. We're going to get our current order. We're going to target its yellow property. And then we're going to target that yellow object's required property. So maybe we boxed 2 out of 3 yellow widgets. And then we got to position, for positioning, we got to explain where is the center of our widgets going to be. So let's look what we did. We did width over 2 minus center offset was red. So width over 2 minus center offset, width over 2. So why don't we do width over 2 plus that center offset? So our yellow one looks like it should go over here. So we're going to add the center offset to push it to the right. So we will do width divided by 2. That puts us in the center plus center offset. All right, let's hold our breath. Let's see if this really complicated function call for draw order squares is going to work. Do we get our yellow widgets? Hey, our yellow widgets are now part of our order. This looks great. Except there's only one problem. It sort of looks like they are already fulfilled based off of the fact that they're all filled in, right? I don't like that. I'd like them to be sort of like empty or hollow in the center and only fill them in as we, get widgets in the correct box. So I really hope that's what mission 4 is going to bring us. Let's see. All right, so mission 4 puts us in that function that we were just calling draw order squares. So we just called it for the yellow box, and it was already done for us for red and blue. So in here, what are we doing? Well, it looks like we're getting a bunch of variables for positioning. So all of those variables that I'm highlighting here are to help us position where these little boxes have to be drawn. And then we're looping through our it looks like we're looping through some numbers, right? We're saying, okay, for I equals 0, I less than required. So if we have to require like required 3 of a given color, we're going to say I is equal to 0, I is equal to 1, I is equal to 2, and then we'll stop because 3 is not less than 3. And I plus plus means go up by 1. So we are going to create, it looks like we're creating a rectangle each time. All right. Well, that's these rectangles. So rectangle 1, rectangle 2, rectangle 3. And then rectangle 1, rectangle 2, rectangle 3. But I don't want to fill in our paint bucket. So if we look here, if I is less than done. So if required, if there was 3 required, okay, and I have, I don't know, let's say 2 done. So if I have 3 required and 2 are done, when we loop through required, I is going to be 0. 0 is less than our 2 done, so I should fill our color. When I is 1, 1 is less than 2 done, so we should fill our color. And then when it's 2, 2 is not less than 2. So this is not going to be true, so we'd run our else statement. I don't want to fill in with our color because we want to change that. So we're going to actually say, you know what? When that happens, let's put no paint in our paint bucket. Let's call no fill. That's going to empty out our paint bucket. So we're going to make sure that we don't use this color that we're passing in to fill in one of our squares if that square has not been fulfilled in the order yet. So there is our logic. This is taking care of all of our squares that represent fulfilled widgets, and this is representing unfulfilled widgets. And then when we draw a rectangle, we use the correct paint. Let's check it out. Ooh, look at that. So right now they are all empty. Let's see. If I put one down here, a yellow, do they fill in? Oh, they should fill in. They are not filling in yet. Why are they not yet filling in? Well, we broke something, but we had to break it in order to fix it because now we see a problem. We start in the right case, but now we got to fill these in as we get them in the correct location. So we got to work on the logic of identifying if a widget matches the correct box. So let's head to mission number 5. Check if a widget matches the correct box. This puts us in a function called process widget boxing. All right, and where are we calling this? Well, if you look just up a little bit, inside update widgets, and if you recall, update widgets runs every single frame of our game. I'll review it again here because it's important for us to know it. P5 gives us some default functions. Setup, which runs once when you restart your game. So right there or right there. And then the draw function, which runs every single frame of our game. And if our current game mode is play, we update our belts, update our player, update our widgets, and update our order. So update widgets is getting called every frame. So we are checking here in update widgets. If we go beyond, if we look here, right here, if we go beyond the width of the conveyor belt, we are removing that widget, but we are also going to process our widget boxing because a widget just fell into one of these boxes. We got to check to see if its color matches the color of our boxes. And if it does, then we did a great job. So the first thing we do is we got to figure out what type of box we are in, okay? So we're going to pass that widget in. We're going to take the widget that we're currently working with and we're going to say process it. So we got to know what box we have. All right, so we have an array or a container called boxes. So you can stay here. I'm going to jump to our gameplay variables. We have this array called boxes. And in here, when we reset our game to defaults, we build these boxes. So here you can see my array boxes has 3 objects. That has an X property, a Y property, a size, and a color. All right, and a type, red, blue, and yellow. So I think what we're going to do is we are going to target that box's type. So we just got to figure out which box we need to look at. Well, this is at position 0 in the array. This is at position 1 in the array. And this is at position 2 in the array. And our lanes have numbers. Lane 0, lane 1, lane 2. So lane 2 is a yellow box, and that corresponds to the yellow box object at index 2 of our array. So that's going to be kind of the way we go about doing this. If we look here, we grab our array and we reach in and we get what is at the position of the current lane the widget is in. So if the widget is in lane 0, we grab the box at position 0 and we check its type. So it's either going to be red, yellow, or blue. Now we want to check to see if our widget's type matches the type of the box that we have. So see how we have it as box type? Right now we're saying if false and current order of our widget type boxed is less than current order of our widget type required, then we would process it. Well, we got to say if it is the correct lane, if it's in the correct lane. So if our widget's type, which is going to be either red, yellow, or blue, if that is equal to our box type, box type variable. If that is true, so it's a red widget going into a red box, and for our current order, our red amount that we have boxed, so our red amount that we have boxed is currently less than the current order's required red widgets. So like maybe I've only got 2 out of 3 red widgets, and I have a correct red widget in line with a red box, we are now going to process our order. So our check is correct here. This is wonderful. We got it all set up. If our widget's color, if our widget's type, red, is equal to the box type it just fell into, red and red, and if the number of box widgets in our order is less than the required widgets in our order, it is time to update our order progress, meaning we just got something correct. So what we're going to do is we're going to take our current order, and we're going to use square brackets. We're going to go to the widget that we have, and we're going to get its type, widget.type, because if you remember, our current order, let's go look at our data structure for our order. Our data structure for our order, where's our order? Okay. Our data structure for our order is red, blue, or yellow. So we are going to go in and access the correct color, red, blue, or yellow, and we are going to access from that property the boxed value. And we're going to say, hey, for that color, we just increase it by 1. You scored a correct box in a correct widget in a correct box. All right, so that increments that by 1. Let's run this and let's test it out. Let's see if it actually goes up by 1. All right, look at that. I don't even got to do any work, but we'll do some work here. We'll put this one down. We'll put this one down. Oh, look at that. They get fulfilled. All right, is this one going to go in? And then our order should be complete. Hey, our order is complete. Well, now what do I do? My order is complete. The meaning of life for me at work is over. I've done my one order. So now we actually got to process this order. So we completed it. Let's look at mission number 7. Mission number 7 is all in the update order function. So we got to check to see if an order is actually complete here. So it says check if the order is complete, compare boxed values to the required values. So I'm creating a constant variable called isOrderComplete. And you notice how it's in parentheses, just like an if statement? So this is a question. And so the question asks for our current order, is its red property, its box property, so the number of red that we have boxed, is it greater than or equal to the current order red property required? So our required red widgets. So we got to make sure did we fulfill all of our red? And false and false. Well, that's no good because we got to mimic this structure for blue and yellow widgets. So we're going to say, okay, not only did we fulfill all of our red requirements, we also are going to check, did our current order, if their blue property, if that is boxed value, if its boxed property is greater than or equal to the current order dot blue, so the blue property dot required. So how many blue widgets did we require? How many do we have boxed? If we've got more boxed than required, we're good there. And then we got to do something similar for yellow. So current order dot yellow dot boxed. So how many yellow widgets do we have boxed? Is it greater than or equal to our current orders dot yellow dot required? Is it greater than the required yellow widgets? If that is the case, if this answers yes, and, so two and signs mean logical and, so each one of these things has to be true. This needs to be true, and this needs to be true, and this needs to be true in order for this whole question to answer yes. And if that question answers yes, the variable isOrderComplete becomes true. And so now If that is the case, this block of code is going to run. So it says, hey, mission 8, order rewards. Award score and spawn a new order. So we want to award a score and spawn a new order. Reset the goal after a completed order. So right here, we get a variable called total required. And so it looks like we're taking the required amount of red in our order, the required amount of blue in our order, and the required amount of yellow in our order, and we're adding them all up. So this is the total number of widgets that were in the order. So I'm going to take our score variable, which we had created way back in the beginning of this video, set to 0, and I'm going to increase it by, let's see, well, total required. So if I had like 5 widgets, I'm going to multiply those 5 widgets by our constant order score value per widget, which I think we set to be 25. So for every widget that we have, we're going to get 25 points. And then we just got to create a new order. So how do we create a brand new order? We have to spawn that order. So that is our spawn order function. So as soon as we finish an order, we get the points for it, and then we spawn a brand new order, and that variable current order gets updated. We'll draw it appropriately, and then we go back to the grind of trying to fulfill that order. So our order system is all set. Let's check it out. Let's see, do we fulfill the order? Do we get points? And do we get a new order? So I got 6 widgets here I got to fulfill. All right. So there's one. I'm getting lots of blue. Okay, so there's a yellow. I need a couple of reds. Okay, so I got my 2 reds. So right now, let's see. I need to get one more yellow in this order. All right, here it is. So I should be getting points, 25 points for each of these. And I got 150 points. Did I get a brand new order? Okay, so there's a chance that could have been the same order. Let's check it. All right, let's just see. Need one more red to come through. Okay, so let's see if we get a brand new order. And I do. Excellent. So there is our brand new order. All right, so this system is working really, really well. But right now, the game's way too calm. I mean, I could work this job all day long finding success. Eventually, we need these conveyor belts to speed up and get faster and faster and faster. We got to implement some obstacles, things that are going to cause the player some harm, get them to mess up their order. We got to make the game a little bit more challenging and a little bit more fun. And the first way we're going to do that is by implementing something known as a difficulty ramp that can help us scale up the difficulty of our game. And we'll do that in our next video. So I'll see you then.